welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as definite integrals. Let's see the sum. Integral of minus pi by 4 to pi by 4 tan cube x sec x dx. Right? Now, first thing you would say is, let us assume that let f of x be equal to tan cube x into sec x dx. Therefore, what will be f of minus x? Wherever there is x, substitute the value of x as minus x. Sec of minus x. Leave the dx out. Now tan of minus theta is minus tan theta. So tan cube minus theta is minus tan cube x. Sec of minus theta is sec theta. So this is going to be minus tan cube x into sec x. So in that case this is going to be minus f of x. So we found out that f of minus x is nothing but minus f of x. Hence I can say that f of x is an odd function. Now if it is an odd function, you can use the formula integral of minus a to a f of x dx is nothing but 0, right? So in that case I can therefore say that I is minus pi by 4 to pi by 4 tan cube x sec x dx is equal to 0. Finally we get this in here. Next, let's see the next one, guys. Integral of minus pi by 2 integral of minus pi by 2 to pi by 2 sec 4x upon second, this is sin 4x upon sin 4x plus cos 4x dx. Right? Now, first thing what we will do is we will check the function. We will say that let us assume let f of x be equal to sin 4x upon sin 4x plus cos 4x dx. So I can therefore say that f of minus x, wherever there is x, substitute the value of x as minus x. Wherever there is x, substitute the value of x as minus x. Wherever there is x, substitute the value of x as minus x. So I'll get f of minus x. Sine of minus theta is minus sine theta, but minus sine x the whole raised to 4 is going to be nothing but sine 4x upon, this is again going to be sine raised to 4x plus cos raised to 4x. Fine, do we get this thing clear? Next, f of minus x is equal to f of x. From here what we realize is that f of minus x is equal to f of x. Hence I can say that f of x is an even function. Now f of x is an even function. In that case I can use the formula integral of 0 to minus a to a, integral of minus a to a f of x dx is twice integral of 0 to a f of x dx. If I use this, I'll get this answer as, let's start with the sum, minus pi by 2 to pi by 2 sin raised to 4x upon sin raised to 4x plus cos raised to 4x dx. This is nothing but twice 0 to pi by 2 sin raised to 4x upon sin raised to 4x plus cos raised to 4x dx. Now this can be, here you could use the formula integral of 0 to a f of x dx is nothing but integral of 0 to a f of a minus x dx. So I can say I is twice integral of 0 to a 0 to pi by 2 sine raised to 4 pi by 2 minus x upon sine raised to 4 pi by 2 minus x plus cos raised to 4 pi by 2 minus x dx. Now 2 integral of 0 to pi by 2 sine 90 minus theta is nothing but cos theta. Sine 90 minus theta is cos theta. Cos 90 minus theta is sine theta. Let us call this as equation 2. Let us call this as equation 1. If I add 1 and 2, let's see this, what do I get? I can say that I plus I, 2i, is equal to twice integral of 0 to pi by 2 sine raised to 4x upon sine raised to 4x plus cos raised to 4x dx plus twice integral of 0 to pi by 2 cos raised to 4x upon sine raised to 4x plus cos raised to 4x dx. So therefore I can say that 2i is 2 common. I can take 2 common. So in that case I'll get integral of 0 to pi by 2 sine raised to 4x plus cos raised to 4x upon sine raised to 4x plus cos raised to 4x dx. So I is integral of 0 to pi by 2 dx, right? Now integral, how did I get this I? Because 2 and 2 on either side gets cancelled. So I get I is x when the limits are between 0 to pi by 2. So I is pi by 2 minus 0. I is nothing but pi by 2. Next, let's move on to the theorems now, guys. Let's start with the theorems. First one, prove that integral of a to b f of x dx f of x plus g of x dx is equal to integral of a to b f of x dx plus integral of a to b g of x dx. Now let's see the sum. Let us assume, guys, that integral of f of x dx is capital F of x and integral of g of x dx is capital G of x, right? Now in that case I can therefore say that integral of f of x dx from a to b is going to be nothing but f of x from a to b, which will be nothing but f of b minus f of a. Similarly, I can say that integral of a to b g of x dx will be nothing but g of x from a to b, which will be nothing but g of b minus g of a, right? Once we have this, then I can do one thing. I can start with my left hand side. First, without the limits, we'll say consider what will be integral of f of x plus g of x with respect to x. Now, from indefinite integrals, we know that this should be equal to nothing but integral of f of x with respect to x plus integral of g of x with respect to x, which would be nothing but f of x plus g of x, right? Therefore, I can say that integral of f of x plus g of x with respect to x from a to b will be nothing but f of x plus g of x from a to b. This is going to be nothing but upper limit minus lower limit. So this is going to be f of b plus g of b upper limit minus lower limit f of a minus g of a. Open the brackets and simplify this, guys. So in that case, this is f of b plus g of b minus f of a minus g of a. This can be written as f of b minus f of a plus g of b minus g of a, which is nothing but f of x when the limits are between a to b, and g of x when the limits are between a to b, which is nothing but integral of f of x with respect to x when the limits are between a to b plus integral of g of x with respect to x when the limits are from a to b. And that's what you have to do. Fine, do we get this thing clear? Next, let's see the next sum, guys. Prove that integral of a to b k times f of x dx is nothing but k times integral of a to b f of x dx. Right? Now, first of all, you will say, let us assume that integral of f of x with respect to x is nothing but capital F of x. Therefore, I can say that integral of f of x with respect to x from a to b is going to be f of x from a to b, right? Which is nothing but f of b minus f of a, right? Once you have this, then I can say that, let's first use indefinite integral formula. I can say, but integral of k times f of x with respect to x from indefinite integral we know is nothing but k times integral of x with respect to x, which is nothing but k times f of x. Therefore, integral of k times f of x with respect to x from a to b is going to be nothing but k times f of x from a to b, right? So in that case, this is going to be nothing but k times f of b minus k times f of a. This is upper limit minus lower limit, right? So in which case I could take k common, so this will be f of b minus f of a, which is nothing but k outside f of x when the limits are from a to b, which is nothing but k times integral of f of x with respect to x when the limits are from a to b. Fine. Next, let's see another theorem, guys. Integral of a to a f of x with respect to x is 0. Now I can say, let us assume that integral of f of x with respect to x is nothing but f of x. Therefore, integral of f of x with respect to x from a to a will be nothing but f of x from a to a. This is going to be upper limit minus lower limit, which is going to be 0. Next, let's see another theorem, guys. Integral of a to b f of x dx is minus integral of b to a f of x dx. Same way, guys, let us assume that integral of f of x with respect to x is capital F of x. Therefore, let's consider the LHS. LHS is integral of f of x with respect to x from a to b, which will be nothing but f of x from a to b, which is nothing but f of b minus f of a. Let's call this as equation 1. Let's see the right hand side, people. Minus integral of b to a f of x dx is going to be minus f of x when the limits are from b to a minus f of a upper limit minus lower limit. Open the brackets, minus f of a plus f of b. which is nothing but f of b minus f of a. All this is equation 2. From 1 and 2 I can say therefore that integral of a to b f of x dx is negative b to a f of x dx. Next, let's see another theorem, guys. Integral of a to b f of x dx is integral of a to b f of t dx. Now, I can say that let us assume that integral of f of x with respect to x is capital F of x. Therefore, and let us also assume that integral of f of t with respect to t is capital F of t. Now, let's see our LHS. LHS is integral of f of x with respect to x when the limits are from a to b, which is nothing but f of x when the limits are from a to b, which is nothing but upper limit minus lower limit. All this is equation 1. Right? Next, let's move on ahead. RHS. Integral of a to b f of t with respect to t is nothing but capital F of t when the limits are from a to b. This is nothing but upper limit minus lower limit. Call this as equation 2. What we see that equation 1 and 2 are the same. From 1 and 2 I can say that integral of a to b f of x dx is integral of a to b f of t dt. Right, so you are allowed to change the variables here. Next, let's see another theorem, guys. Integral of a to b f of x dx is integral of a to c f of x dx plus integral of c to b f of x dx. Now, let us assume that integral of f of x with respect to x is capital F of x, right? Let us see the LHS. LHS is integral of f of x with respect to x when the limits are from a to b, which is going to be nothing but f of x when the limits are between a to b, which is nothing but f of b minus f of a. Let's consider the right hand side. Call this as equation 1. Right hand side is integral of a to c f of x dx plus integral of c to b f of x dx. This can be written as f of x when the limits are from a to c. This can be written as f of x when the limits are from c to b. This is nothing but f of c minus f of a plus f of b minus f of c. Upper limit minus lower limit, right? Plus f of c minus f of c gets cancelled. This is nothing but f of b minus f of a, which is equation 2. From equation 1 and 2, I can say that integral of f of x with respect to x from a to b is nothing but integral of a to c f of x with respect to x plus integral of f of x with respect to x when the limits are from c to b. Next, let's see another sum, guys. Integral of a to b f of x with respect to x is integral of a to b f of a plus b minus x with respect to x, right? Let us assume that a plus b minus x is equal to t. Differentiate with respect to x. So minus 1 is dt by dx. Therefore, I can say that dx is minus dt. Now, since I am substituting, I have to substitute the limits also. The value of x is a and b. Now, when x is a, if I substitute the value of x as a in this equation, I'll get t as b. When I substitute x as b, I'll get t as a. Let's start with the right hand side. Integral of a to b f of x f of a plus b minus x dx can be written as, instead of a I can write b, instead of b I can write a. T dx is nothing but minus dt. Get the minus sign out. F of t dt. You could use the formula integral of a to b f of x dx is nothing but minus integral of b to a f of x dx. This is nothing but, if I remove the negative sign, I have to change the position of limits. So this is going to be a to b f of t dt. Now I could use the formula integral of a to b f of x dx is nothing but integral of a to b f of t dt. If I use this formula, this is integral of a to b f of x dx, which is my LHS. Right, that finishes that sum. We'll stop this here for the day. Thank you very much.